All right, so 5-4 continues with logs and exponential. Now we're solving logs and exponential equations. So these are some that can be done without a calculator and then some that can be done with. So like I'll kind of highlight as we go back and forth, but you're definitely going to see a mix of both. So without the calculator would be on next week's test, but it could still be using the properties that you need for Friday, which is the calculator part. So there are really 3 overall types of equations that you're going to solve when you're dealing with exponential. The first is if you can change the base to be the same on either side of the equal sign. So if I have exponential, something to the power and something to the power, and I can change them both to be the same, then this is our 1-to-1 property. We change them both to be the same, and then we set our exponents equal to each other. So those we've already done, right? If I had 2 to the x equals 4, let's just say, I would rewrite that as 2 to the x equals 2 to the second, and then I would set my exponents equal to each other. That's what that means. Can you rewrite it so they have the same base? The second is if e is on one side of the equation. So if I have e to the x, let's say, equals a number. The opposite of e, or the inverse of e, is actually ln. When I ln e, so we're going to make ln a verb. When I ln e, those cancel out and just give me the exponent. But whatever I do to one side of the equation, I have to do to the other. So when we get something like this, we would ln both sides of the equation. Ln of e cancels out and leaves you just your exponent. And then it would equal ln of 10. Without a calculator, it stays that way. With a calculator, like on Friday's test, I would type in my calculator ln 10. I think we said 3 decimal places, so I would get 2.303. So if you have e on just one side of your equation, you might have to work to get it alone. You might have to isolate it just we do with x when we're solving equations. But then you are going to ln both sides of the equation. The ln of e cancels and gives you just what's in the exponent, and then you still have the ln on the other side, and you'll work through that. The third is, what if the bases can't be changed to be the same number? So this would be something like I have 3 to the x equals 7. I cannot rewrite 7 as 3 to the power, okay? For these, we do the same thing. Well, this one says convert to exponential and change the base, so I'm going to teach you 2 ways. The other thing is ln both sides. So if I want to convert this, here, I'm going to just teach you the second way because I think it's easier. If I have this, if I cannot change the base on either side, I'm going to ln both sides of the equation again. And I end up with ln of 3 to the x equals ln of 7. I bump the exponent to the front using the properties of logs. So this comes to the front. I get x ln of 3 equals ln of 7. And then I divide both sides by ln of 3. And I would get x equals ln of 7 over ln of 3. You have to be careful when you type that in the calculator. It opens this parentheses. You've got to close the 1 after the 7 if you do it all in one. So you can either do ln of 7, enter, divided by ln of 3, or you can do ln of 7, close your parentheses, divided by ln of 3. So I get 1.771. So the other way this says to do it, you're converting the exponential to a log and then using change of base. So if I start with the same thing, convert this to log, so the 3 is the base on the log. This would be 3 on the base. The 7 comes over here with the 3 equals x. And then I can use the change of base property on this, which says log of 7 over log of 3. And that would give you the same as ln of 7 over ln of 3, right? Log of 7, ln of 7 are the same. Log of 7 over log of 3 would be the same as ln of 7 over ln of 3. You'd get the same answer. I tend to recommend the first process because although it might look like it's one more step here, these are going to get more complicated, and when they get more complicated, it's going to be harder to convert them into log from exponential. So you can always ln both sides of the equation. So the hardest part, like if you get feedback at the end of this chapter for most people, is figuring out what to do when. And this is part of it. So with these are all exponential. With exponential, you either want to see if I can change the bases to be the same. If I can't, I'm going to ln both sides. Whether it's just one e on one side or if it's two numbers on bases on both sides, you're going to ln both sides of the equation. And those would require a calculator. All right, so look at 1. Are the bases on both sides of my equal sign the same? Yeah, even though they're e, they're still the same, right? So I could literally just disregard the bases and keep the exponents. Negative x squared equals negative 3x minus 4. Now what? Good. You're going to have to factor, so get everything on the same side. I would prefer a positive x squared, so I'm moving from left to right here. You could go the other way. Now I factor. Factors of negative 4 that sum to negative 3, negative 4, positive 1, and then split and solve. So x is 4 and x is negative 1. And these are one with time and a calculator. You could check. I could plug those values back in and make sure left side equals the right. Notice we didn't need the calculator for this, so this kind of question would be on next week's test. Any 1-to-1 is going to be next week. Okay, 2, same thing, right? Bases are the same on both sides. Just set my exponents equal to each other. 2x equals x squared minus 8. I've got an x squared and an x again, so I'm going to get everything to one side. 0 equals x squared minus 2x minus 8. X minus 4, x plus 2. Split and solve, and I get 4 and negative 2. Okay, this would be 3. That 3 is not part of the question. That would be 3. Now what? Can you change the 42? Well, first of all, we don't have just a single base on the left-hand side. So the first thing I would want to do is get rid of that 3. Divide both sides by 3. 2 to the x equals, I can't do the math right now, 14. Yep.
Wait, so you can't just like multiply the 3 and the 2?
No, because only the 2 has that exponent. If the exponent was on the outside and the parentheses were in the 3 and the 2 were the inside, then you would do that. But that exponent is only for the 2. All right, can I change 14 to be a power of 2? No. So this is, we're going to ln both sides of the equation. So I put ln over here and I put ln over here. What happens to the exponent when we ln? Good, gets bumped to the front. So this becomes x times ln of 2 equals ln of 14. And then I would just divide both sides by ln of 2. Without a calculator, my answer would say like that, ln of 14 over ln of 2, with or without the parentheses, doesn't matter. With a calculator, you would take it to the next step. So ln of 14, close my parentheses, divided by ln of 2. And I get 3.8073. Have you guys ever heard of truncating a decimal? Ever heard that term? So truncating a decimal means literally don't round, just stop at that decimal. So I wouldn't have even had to look at the 3, I just drop it at the third decimal. So apparently, and I don't teach AP Calc, but apparently at some point Miss Ferry just like does that. Like you just drop off decimals and you don't round. So she told her kids that she would take either answer. I'm gonna do the same. So if it says to round to 3, you can also truncate to 3, which means literally go to the 7 and stop. Don't even look at the 3 to see if you have to round up or not. Does that make sense? So there's no rounding up. It's just stop. Does that make sense? Yeah, okay. So I'll do what she's doing. Either answer will be taken for your test or quiz. All right, what are we gonna do with 4? Divide by 2. 5 to the x equals 16. Can't change 16 to be a power of 5, so I'm going to ln both sides of the equation. The x bumps to the front. X times ln of 5 equals ln of 16. and then divide both sides by ln of 5. ln of 16 divided by ln of 5, x equals 1.7227. So if I'm rounding it, it becomes 1.723. If I truncate it, it's 1.722. So either answer is fine, and I'll look at what Webb sign does. I think it rounds. Good so far. All right. Now we've got e on one side of the equation, but it's not by itself. So the first thing you have to do is work to isolate that e. So I'm going to subtract 5 from both sides of my equation, and I get e to the x equals 55. Now I cannot change them to have the same base, and it's also e to the x. So the same process applies for both of those cases. I'm going to ln both sides of the equation. The difference is with these and the base that's a number is that ln of e cancels out. I don't have to bump the x to the front. This just becomes x equals ln of 55. Now, if you didn't remember that, hang on, let me finish this and then I'll show you what I'm talking about. 0, 0, 7. If you didn't remember that and I got to this, ln of e to the x equals ln of 55, and I bumped the x to the front, and I divided both sides by ln of e. ln of e is 1. So even if you type that in the calculator, you're going to get the same answer. It just saves you a little bit of work. Anytime you get ln of e, cancel it, keep the exponent. All right, so what are you going to do first for 6? Add the 7. E to the x equals 30. Then ln both sides. This becomes x equals ln of 30, which if I didn't have a calculator, I would say that way. But with a calculator, ln of 30, 3.401. All right, what do you think we're going to do first with 7? Add the 4, good. Just like you would normally solve that equation, we're going to eventually want to isolate what we're solving for, which is the exponent. Then what? Divide by 2. Now I'm going to leave it as 15 over 2. You can make that 7.5, but they're not all going to round. So if that was like a divided by 3 and it was a decimal of 0.333, something like that, I wouldn't want to do it. Because it's divided by 2 and it would actually terminate, you could. You just have to keep the decimal, okay? But I'm going to keep it as 15 over 2 just because you're not always going to be able to do that. Now what? How would I get rid of, how am I going to get rid of this exponent? I can't change these to be the same base, right? ln both sides of the equation. The exponent bumps to the front. So this time it says 2x minus 5 times ln of 3 equals ln of 15 over 2. Now what? You actually have 2 choices here. You can divide both sides by ln of 3, or you could distribute ln of 3. So let's say I divide by ln of 3. I'm going to keep this exact as long as I possibly can. So the right side of this equation is going to get messy until I type it in the calculator all the way at the end. But I don't want to start rounding as I go. So this is gone. Now I have 2x minus 5 equals ln. And I could make it 7.5, or I keep it as 15 over 2 over ln of 3. Then what? Add the 5. ln of 15 over 2 over ln of 3 plus 5. Then what? Divide by 2. So that whole thing is going in my calculator. This is where you got to be really careful how you plug things in. So order of operations is going to it's not going to do what we want it to do unless we close the parentheses after that 15 over 2. So the first thing I'm going to type in is ln 15 divided by 2. I'm going to close my parentheses. Or I could hit enter, but I have to keep that exact. I keep having to use answer. I can't round it, okay? Then I'm going to divide that. So I did this part. Then I'm going to divide that by ln of 3. Now I've done this whole part. Then I'm going to add 5 to it. Now I have my numerator. And then I'm going to divide 2. And I get x equals 3.417. So this is where you have to be so careful when you're typing, because they're going to get complex like that. Like your answers are going to have multiple steps before you plug it into the calculator. You got to be really careful. One, you want to give me this whole thing like on paper so that if you just type it in the calculator wrong, I can give you partial credit. But also you got to be really careful when you type that in. Yep. Okay, go to 8. Step 1. Actually, all right, so you should have gotten negative 4.778 or 777 if you truncated. Raise your hand if you got it. Okay, good. All right, so if you had the time, and that's a big if, okay, because you're not necessarily always going to have the time. But if you have the time, you can actually check these answers by plugging them back in. It gets just as messy with the calculator as you're checking, but you can totally take this number and I can plug it back in here, and I can plug that in the calculator. 6 and then 2 negative to the negative 4.778 plus 5, get that answer, add 4, and see if it gives you 11. It's not going to give you exactly 11 because we rounded it, but you should be pretty close to it. So you can always check these answers too to see if you're on the right track. Questions so far? Okay, look at 9. Can I change those to have the same base? No. So I'm going to ln both sides of the equation. So I get ln of 3 to the 2x minus 1 equals ln, and that's a 0.4, to the x plus 2. Exponents bump to the front. This time there's an exponent on both sides. Now I have 2 x's, one on the left and one on the right. So this one, it gets a little sloppier. I have to distribute. I can no longer divide. If I divide, it just moves back and forth between the sides. So I have to distribute these ln's. I'm going to distribute the ln 3 to both the ones on the left. I have to distribute the ln 0.4 to both the ones on the right. So I'm going to distribute it. And the order there doesn't matter. It could be 2x ln 3 or it could be ln 3 times 2x. Like the order of, it's all multiplication, so it doesn't matter. So I tend to put the x on the front and then ln of 3 minus 1 times ln of 3, which is just ln of 3. I'm going to do the same thing on the other side. So x times ln 0.4, careful, don't lose the decimal, plus 2 ln 0.4. Now I have 2 x's, so I got to move those both to be on the same side and then the constants to be on the other. So I have to subtract x ln 0.4 from both sides. I get 2x ln of 3 minus x ln 0.4. I'm going to do this in the same step. Add the ln to the other side. So the one without the x goes to the other side. Equals, this one's gone, 2 ln 0.4 plus ln of 3. So both terms that have an x go to the left. Both terms that don't go to the right. Now I'm trying to isolate the x, so I have to factor the x out. I take the x, I put it on the front. And I'd get 2 times ln of 3 minus ln 0.4 equals, and I have that whole thing, 2 ln 0.4 plus ln of 3. Now how do I get x by itself on the left side? This is multiplication, right? Divide that whole yucky thing by it. 2 ln of 3 minus ln 0.4. And then I have to type that whole thing in my calculator. So 2 ln 0.4, make sure you close the parentheses, plus ln 3. I hit enter on that because I didn't put the parentheses at the front, so I'm doing just the numerator, so I have all of this now. Divided by, and I have to group this together, 2 ln of 3 minus, close the parentheses, so they're here, ln 0.4. And I get x equals 0.2357. So 236 is what it would round to. In my opinion, these are the hardest ones. And you will see stuff like this, okay? But these to me are the hardest ones because you have an x on both sides or equal sign. So you're going to have to ln both sides. You're going to have to bump to the front the exponent. You're going to have to distribute, and then you're going to have to get both terms with the x's to one side, both the terms without the x's to the other, and then factor it out. On my calculator, this is negative 0.236. Yep. And again, I can plug it back into check. So I can let my calculator do that work. I would do 3 to the 2 times what I just got minus 1. See what that is, and then 0.4 to the what I just got plus 2 as the exponent, and see if those are the same. They won't be exact, but they should be close. All right, we're going to do it again. This one's a little bit easier, but the same process. I think that's the hardest question. They get different, but I think that's the hardest question. All right, so I've got 2 to the x plus 3 equals 5 to the x. We're going to ln both sides again. X plus 3 bumps to the front. This would bump to the front. X times ln of 5. I have x on the left and an x on the right, so I'm going to have to, I can't just divide by ln of 2. It's not going to go away. So I got to distribute here. I'd get x times ln of 2 plus 3 ln of 2 equals x ln of 5. I got to move the ones that have x's to one side, keep the constants on the other. So I'm going to subtract x ln 2 here. And I get 3 ln 2 equals x ln 5 minus x ln 2. I got to take out the x, ln of 5 minus ln of 2. And then divide both sides by that. Ln of 5 minus ln of 2. So 3 ln of 2 is my numerator. Divided by, I'm going to group my denominator, ln of 5 minus ln of 2. And I get x equals, this time it's positive, 2.269. They look so very complicated, and I promise you if you can factor, you can do these, okay? This is a factor question disguised in an exponential question, okay? So if I were to, and I'm going to show you 2 ways, but hopefully once you understand it, you would stick. I think the second way is easier. But if we go back to our substitution, you remember if we took a and we said that a was the middle term, then we could change this to be a squared minus 3a plus 2, and we could factor it out. So that's the first way I'm going to do it. A is the middle term, so a is 3, or e to the x, sorry. So e to the 2x would be a squared minus 3a plus 2. Then I would factor it. So factors of positive 2 that sum to negative 3 would be a minus 2 and a minus 1. Then I would split and solve this, so a would equal 2 and a would equal 1. But we made a, so we have to plug back in what we replaced it with. We replaced, or we made we made e to the x a, so we have to replace that, plug that back in. And now I have 2 exponential equations. Both are e to the x equals something. How do I get rid of the e to the x? ln both sides. So ln of 2 would equal, these cancel out x, and this x equals ln 1. Type that in the calculator. ln 2 is 0.693. And ln of 1, I don't even need to type in the calculator because any result of an exponential function being 1 should be 0. But if you forget, you could type that in. Ln of 1 is going to be 0. So those are my overall answers. It would be 0 and 0.693. They're playing for you.
Why is this class thing for the videos and the other
I don't know. It's not always just you guys, yeah.
Why, like, when you put the ln, why does it, like, change?
So why does it change the e to the x, you mean? Or why does it change?
Yeah, like, where does it...
Because ln of e is the exponent on the e, the result of it. ln is log base e, right? So ln e is log base e of e. When the base on the exponential function and the base on the log are the same, we keep the exponent. If there's no exponent visible, this is just 1.
So then the exponent just goes to the other side.
Yep. Or you just lose the whole log. So if it's ln of e to the 5th, it's just 5. Because it would be log base e of e to the 5th. Oh, you mean if you converted it to exponential?
No, like e to the x equals 2. How did you do that?
I ln both sides, right? So you have to change both. Whatever you do, one you have to change the other, right? So ln of e to the x just becomes its exponent, which is x. Does that make sense?
Yeah.
And then the ln of 2 stays.
Okay.
Yeah, sure. All right, so I'm going to do the other method on this one because I'm telling you it's easier. Like, people see these and freak out, but I promise you, it's just factoring. The first term is always going to be e to the x, so we treat that almost like we would treat our x. And then you would disregard the e's. Look for the factors of the last constant that sum to the middle term. So what are the factors of 12 that sum to -7? -4 and -3, and then you split and solve. So e to the x would equal 4, and e to the x would equal 3, and then we ln 4 times. So this becomes x equals ln of 4, and this becomes x equals ln of 3.
You recommend this way for every time you do that?
I think it's faster.
There's no exception, right?
I mean, there are, like, outside of what we're going to do, they could make they could put something on the front of the e to the x or e to the 2x or whatever, but it's not going to happen. 1.0986, so it's 1.100. You asked that question. If that was positive, if when I factored it, I got e to the x plus 3 equals 0, and then I move the 3 to the other side, and I try to ln this, you can't ln a negative number. I will get an error, which means that this would not be a solution and only the other one would. And if they were both negative, it'd be no solution. And your calculator will yell at you. Like, you can't find the log of a negative number or the ln. Questions on those? So good old factoring comes back, but it's relatively easier factoring. Okay, that's all the exponential stuff. Then we get into solving logs, okay? So solving log equations, it's a marathon of a day, but we're going to power through. And then you get 2 full days of review, which is better, okay? Solving log equations have these options. And some of them, just like the exponential we've done before. If there's only one log, we're going to put the equation into exponential form and solve. We've done this. So if it says log of 3x equals 2, let's say, like that, we can convert this into exponential. So 3 would come over and pick up the 2, and I would get x equals 9. That's what that means. One log, just convert it to exponential, and then solve. The second method is if there's one ln. If there's one ln, it basically means there's one log, because ln is log base 3. So if this said ln of 3 equals, well, here, I won't go like this, of x equals 3, I would rewrite that to log base e of x equals 3, and then e comes over and picks up the 3, and I would get x equals e to the 3rd, or 20.08, I must be 0.0855, so 0.86. So first one is just one log. Second one is just one ln, which is one more step because you got to convert it to log first. The third one is if there's one log on either side of the equal sign. We have done these two. If it says log of this equals log of this, same log on either side of the equal sign, we ignore the logs and we use the one-to-one property. So if you remember these, this said like log of x plus 3 would equal log of 10. Something, well, not 10. I should use a different one because that's simplifiable. Okay? Log like that. If it's the same log on either side of the equal sign, we would just say x plus 3 equals 15 and x equals 12. Here's what's new, multiple logs. Whether the multiple logs are on one side of the equal sign or on both sides of the equal sign, based on what we learned yesterday, we know how to condense that. So if there's multiple logs on one side or both sides of your equal sign, you are going to condense them down. So if it's log blank plus log blank, it becomes multiplication. We're going to condense it down to one log and then solve it, however, based on what we already did. So that would look like this. Log, let's say, of x plus log of 3 equals, and this could either be a number or another log. So we'll do both. It would be like log of 21. So I've got two logs on one side of my equal sign. The first thing we do is condense. If it's addition, it condenses to what? Multiplication. So this would be log of 3x equals log of 21. Same log on either side of the equal sign. So one-to-one property tells me I can totally ignore it. And I get 3x equals 21. Divide by 3. And x is 7. The other way would be if it's the same on one side. So the left side still has multiple logs. I want to condense it into one, so it's still addition, which means multiplication. But now how do I solve that? Only one log. So you only want to ln if there's not already a log or a ln in it. Almost. What's the base on that log? 10. So now the 10 picks up the 2, drops off, leaving the 3x. So 100 would equal 3x. And then I divide both sides by 3. And x is 100 over 3, which would be the exact answer. If I had the calculator, it would be 33.3 repeated. Yep. So which one? Say again. Oh, no. Okay, so then one of the most important parts about this is that last statement. Log expressions are defined only for logs of positive real numbers. If you get an answer that when you plug it back in requires you to find log of 0 or log of negative, you cannot keep that answer. It's an extraneous root. So it doesn't mean you can't have 0 or you can't have negative as an answer. It means that when I plug it back in, it can't be finding log of it. So like if I look at this one, for example, if I get x is 7, then I want to come back up to my original question. Everywhere there's a log with an x next to it, which in this case is only this one, I want to make sure that this would not result in 0 or a negative. That's a positive 7. I can find the log of 7. It's fine. If I had gotten negative 7 here, and when I plug it back in, I'm trying to find the log of a negative number, I cannot keep it. I would cancel it out and say no solution. Usually that kind of stuff happens when you have like something that you end up factoring along the way, and you get two answers. That's usually when it happens, but you always want to check when your initial questions are log. So when the initial question says log, remind yourself, like put a little star, something to make sure you remember to check it. All right, I'm going to do at least one example of each of these, and then we'll save some for tomorrow. So look at 13. What am I going to convert that to? Log base e of x equals 3. Then what? E comes over and picks up the 3. And e to the third, we just did that, right? 20.086. Man, I came up with that same example, and I haven't seen these notes in 365 days. It's pathetic. All right, I would do the same thing for 14. Log base e comes over, picks up the 2. Easy stuff, right? What are you going to do for 15? Ignore the logs, set the other ones equal to each other, okay? What are you going to do for 16? Condense the one side. This time, what's between them? A minus, which means divide. So this becomes 3x plus 14 over 5 equals log base 6 of 2x.
But they had different bases.
You can do it. It won't. Yeah, good question. If you had different bases, you couldn't condense. All right, so now one-to-one property, right? Ignore what's here. 3x plus 14 over 5 equals 2x. Multiply both sides by 5. 3x plus 14 equals 10x. Subtract the 3x. God bless you. God bless you. And divide by 7. Oops. And I get x equals 2. So here's an example. I should have done this up here too. I should have checked to make sure I can plug that back in. But when I get that 2, I want to come back up to my original question. And everywhere there's a log next to something with an x, I need to plug that back in. So I would make sure that 3 times 2 plus 14 is a positive number. I don't care what it is as long as it's positive. So 6 plus 14 is fine. I would take and plug in a 2 here, and I would make sure that's positive. 2 times 2 is 4, and that's fine. Did I screw up again? Oh, okay.
Where it's purple, could you just divide the other side by 1/2? I mean, divide by 2.
Divide with, yeah, sure. You can do the same thing, yeah. So because neither of those cause a problem, you can keep that 2. What are you going to do first for 19? Subtract the 5. 2 ln of x equals negative 1. Then what?
Put it into 2
Wait, say that again. Oh, you can. Before I can pick it up, though, you got to get rid of the 2 on the front first. So you can do that, like 2 log base e of x. But before I can pick, the e can go over and pick it up, you got to divide by 2. So now ln of x equals negative 1/2. And then log base e of x equals negative 1/2. E comes over and picks it up. E to the negative 1/2 equals x. And then let your calculator do that work. E to the negative 1/2 is 0.607. Make sure you can find log of that or ln of that, which you can because it's positive, so you can keep it. We'll come back to 20 because it's just like that one. Okay, go to 21. What do you do first? Divide both sides by 2. So I got to get that log by itself before I can convert it to exponential. Now the 5 picks up the 2. 25 equals 3x. Divide both sides by 3. And x is 25 over 3. So if it didn't tell me to round, I don't have the calculator. I'm going to keep that exact as 25 over 3. If it says what to round to, then I would round that. I would put that in the calculator and I would round it. 22 is just like that. We'll do 23. Okay. Now we're condensing. So log 5x times x minus 1 would equal 2. So I get log of 5x squared minus 5x equals 2. Now it's 1 log. So the base on that log is 10. The 10 is going to come over and pick up the 2. 5x squared minus 5x would equal 10 squared, which is 100. As soon as you see that squared and the non-squared, you know you're going to have to get everything to one side and factor it. This time I can make my life a little bit easier because what goes in all that? 5. This would be x squared minus x minus 20 equals 0. And then I get x minus 5 and x plus 4. Split and solve. And I get x equals 5 and x equals negative 4. Now I got to check. If I plug in 5 into both of these, Positive 5 is fine. I get to keep it. But if I plug in negative 4 here, I'm trying to find log of negative 20, which you cannot find. I rule out the negative 4 and keep only the 5. Questions on that one? Yep.
So you know you pull out a 5. If that's a different number, that also be a solution. If 5 equals.
Oh no, it's just totally coincidental. Yep. If I pulled out like a 5x, now I have an additional solution, but the 5 is gone. Yeah. Okay, we can come. This one would be again multiplication, again conversion. So that's just like that one. Let me see what's on the next slide. This one is that one-to-one property. We can do that tomorrow. All right, I'm just going to walk you through because you're going to see some of these. For this, like 26, I would want to move the logs to be on the side together and then keep the 3 on the other side. Then condense it and then convert it to exponential. 27, you're going to have to ln both sides. 27 is just like the ones all the way at the beginning. Notice they're getting mixed back in. This is how it's going to happen for your test. You're going to get exponential mixed in with logs. 28, you're going to condense and then solve, and 29, same thing. 2 goes over, picks up the 3 halves, and then you would solve from there. So I'm going to give you, this is a long homework assignment. I'm going to give you until Thursday to have it done, but I need you to at least like try to do half tonight, at least. Even if you have to pick and choose through them to do the ones that you're comfortable with and then ask questions tomorrow, that's fine. But I need you to not wait until tomorrow to start it, okay? So I want you to do at least half of the homework that's on WebAssign for tonight. And then tomorrow we'll go over that. We'll do the extra examples here and we'll talk a little bit more about the test part 1. That's Friday.